if you say the reaction is kinetically fast, so what are you going to check for that? Activation energy, yes. And for thermodynamically controlled, thermodynamically stable, what are you going to check? You're going to check low energy, stable, low energy. So based on this, you can easily identify which reaction is kinetically fast. Yes, more low energy, like here. These are reactions 1, 2. This question you have already done with me in the last class. 1, 2, 3, 4, 5. Which reaction is thermodynamically very favorable but kinetically not favorable? Which one? Which one is thermodynamically favorable but kinetically not favorable? Yes, Sammy. For the thermodynamically, for the kinetically, you are going to check the activation energy. Yes, reaction 3. Because reaction 3 has very high kinetic energy. Very good, Sammy. Perfect answer. And which reaction is kinetically favorable as well as thermodynamically favorable? Reaction 5. So this topic we have already done. You can do the quiz based on this topic on the website. So we have already understood the thermodynamic quantities. You already are aware of delta H. Unit 6, enthalpy change. The heat content at the constant pressure. You are aware of this delta T, change in temperature, delta P, change in pressure, delta V, change in volume. And in this unit, you are going to learn delta S, change in entropy, and you are going to learn delta G. All these which I have written here, these are state functions. State functions. And state functions, they depend on, yeah, children, state functions, they depend on initial and final state. You remember in unit 6, initial and final states. And nothing doing with the path. Like delta H, what is delta H? We did the equation. Delta H of the reaction is the summation of delta H naught formation of the products, whatever products are there, minus summation of delta H naught formation of the reactant. This equation is there because it's a state function. It depends only on the reactant and products. It doesn't depend on the intermediates or in between whatever path they are following. Exactly in the same way, the way I've written delta H reaction, you can write delta S. So what is delta S reaction? Same equation. Is the summation of delta S naught of the products. Products. You can put formation here. Minus delta S naught formation of the reactant. Same equation. And then same equation for delta G. Delta G reaction is also the same thing. Summation of delta G formation of the products minus summation of delta G not formation of the reactants. We did questions based on this one earlier in unit 6. Today you are going to do questions based on this in this unit. And Hess's law. If you remember the Hess's law for delta H, Hess's law is also based on state function. So you will use the Hess's law on these also because they are also state functions. So state functions are, they depend only on initial and final. They don't depend on the path. Okay, so these are the thermodynamic quantities. And now I'm taking you on the second law of thermodynamics. What is the first law of thermodynamics, children? First law, any one of you? Energy of the universe is conserved. Energy of the universe is conserved. That's the first law of thermodynamics. The second law of thermodynamics is entropy of the universe is increasing. Now, what is entropy? Entropy is the, yes, measure of randomness. Measure of randomness, disorderness, randomness. Now, if you look at the entropy of this solid, compare it with liquid, with gas, you can see the entropy is increasing. And gases have the highest disorder, highest. Can you see here's a double arrow like this? So gases have the highest entropy. And nature wants increase in entropy. Nature is in favor of increase in entropy. So entropy of the universe, you already know that universe can be divided into two parts. One part is system. This we have done in unit 6. Other part is surroundings. System and surroundings. Yes, Sammy, very good. System plus surrounding is universe. Universe is system plus surroundings. Right? And entropy of the universe, the change in entropy. Right now we are talking about change in entropy. Change in entropy is the change in entropy of the system plus change in entropy of the surroundings. So that's the total entropy of the universe. And entropy of the universe, if it is less than zero, if this change is less than zero, then what does it mean? It means that process will not take place. The process in which the entropy of the universe is decreasing will not take place. Only those processes will take place where delta S universe is greater than zero. This one. This process will not take place. So this at delta S, if it is negative, no reaction, no change. But if it is positive, yes, the process will happen. So we are going to understand this concept in detail. So that's the second law of thermodynamics. Okay, now let's see how to understand the change in entropy of the system and the universe. This is slightly confusing. So when I'm speaking, trying to teach you these things, please keep asking questions because you'll get confused. If you don't ask anything, you're just listening, there will be so much confusion. So children understand when I'm talking about this, I'll talk about the system and surroundings. Okay, let's see. This is the system, water. This is the system in this container system, right? The liquid is getting converted into gas. What is happening to entropy of the system? Entropy of the system increasing or decreasing? Increasing. So positive sign. Now listen to me very carefully, okay? Yusuf, you're there? Change your name, Yusuf. Okay. So here liquid to gas, entropy of the system is increasing, right? Positive. Agreed? Now, is this process endothermic, exothermic? You're supplying heat. The process is Endothermic. Endothermic means positive sign again, sign convention. Anything added to the system is positive. Now, when the entropy, from where this heat is taken, from where this heat is coming, children? From the surroundings. So, what is happening to the entropy of the surroundings? Heat, temperature is directly proportional to kinetic energy. So, the entropy of the surrounding is decreasing. If entropy of the system is increasing, entropy of the surroundings will decrease. So, what will happen to the temperature of the surroundings? What will happen to the temperature of the surroundings? Temperature of the surrounding will decrease because heat is withdrawn from it, right? Okay, this is clear. Okay, now let's say entropy of the system is increasing and entropy of the surroundings and delta H of the system is also increasing, that's endothermic. Delta H of the surroundings, okay, I have to change this. I think I have to revert it. Okay, so please, I'm going to do some correction. Pay attention to the correction. I'm writing the reverse process. Reverse. H2O gas to H2O liquid. Now let's do correction in this. So delta H of the system increasing or decreasing? Check here. You are going from gas to liquid. So entropy of the system is decreasing, negative, right? Is this process endo exo? This one, gas to liquid. Gas to liquid is? Mhm. It is exo. So where the heat is going? Where this heat is going? This heat is going to the surroundings. Yes, children. So what is happening to the entropy of the surroundings? Entropy of the surrounding is increasing. So when entropy of the system is decreasing, heat flows from the system to the surroundings. So heat is always flowing from high temperature to low temperature, heat direction of flow of heat, right? So delta S of the surroundings, it depends on the direction of the heat flow. Like here, heat is flowing to the surroundings. So delta S of the surroundings is more than zero because heat is going there and heat is temperature is directly proportional to kinetic energy. If heat is going to the surroundings, temperature is going up and kinetic energy is increasing. Children, are you getting it? You're understanding? Now, here, what I'm trying to tell you that if the delta S of the system is positive, surrounding is negative. If the system is negative, surrounding is positive. Correct? And it depends on the flow of the heat, in which direction the heat is flowing. And heat, we measure heat in terms of enthalpy, heat content. And it depends. The flow of the heat is always from high temperature to low temperature. So it also based on the temperature. So delta S of the surrounding can be measured. Understand this equation now. I'm writing the equation. Delta S surroundings is minus delta H system over temperature. That's the equation. Because you see that here, okay, there is correction needed here. This is negative. This is negative. Negative means exo. If the delta H of the system is negative, if I plug in negative value here, that negative and negative will make surrounding positive. That's why the equation is this. Okay, or you can see delta S surroundings is minus delta S system, which is equal to, this minus is there, right? Minus delta H system over temperature. This is how you can measure your delta S surroundings. Children, is it okay? System and surroundings, you're already aware from unit 6. That's the equation I'm talking about. This one. And this delta has surroundings, this one. System is very small as compared to surroundings. System is very tiny as compared to surroundings. And for a process to take place, remember I said delta S universe should be greater than 0. So they say that this delta S surroundings can be considered as your delta S universe. So the surrounding entropy, whenever it is positive, increasing, that process will be spontaneous, can take place. I think I told you the meaning of spontaneous and non-spontaneous. An object falling down, spontaneous, non-spontaneous. An object falling down is spontaneous or non-spontaneous? An object going up. Okay, Sammy, you have to think. When the object is going up, is it going up on its own or you have to supply energy? Falling is spontaneous. Going up is not. Sammy. And rest to those who are not answering. When the something is going up, you are working against gravity. Continuously you have to supply energy. You stop supplying energy, it will not go up. So that's a non-spontaneous process. Non-spontaneous, right? And when the object is coming down, it is working with the gravity. Gravity is helping us. So that process will be spontaneous. Formation of days and nights, spontaneous, non-spontaneous. Formation of days and night, spontaneous. Because they happen on their own. You're not doing anything. Growth of your body, spontaneous. Of course, you need food. But even if you have seen that, even if you don't eat much, your body will still grow. If you are eating less, the growth will not stop, right? So some processes in the nature are taking place on their own. We don't require anything for that. Those processes are spontaneous. Similarly, driving forces which can give energy, generally they are considered in terms of delta S surroundings. When delta S surrounding is positive, then that process will be spontaneous. Okay, and that delta H is minus delta S system over T. Are we okay with this equation, children? I explained you already how the amount of heat and temperature is going to decide your delta S. So just focus on the equation. Okay, now here are some questions, very simple questions. Let's do them fast. You have to predict the sign of delta S naught. Predict the sign of delta S naught. From this to this, the randomness is increasing or decreasing? In the A part, Yes, very good. It's negative sign. Predict the sign, okay? Negative. B part. Randomness is increasing or decreasing? In the B. Sammy, good. Your answers are perfect today. B part, what's the answer, children? It's decreasing, Atharva. Very good. Decreasing, negative. C part, from 2 moles, these are gases. Can you see these are gases? This is liquid. Increasing, decreasing. Very good, Yusuf. Decreasing. D part, liquid to gas. Liquid to gas. Increasing. So this is minus and this is plus. So these questions are there in AP exam. Entropy questions will be simple. I'm trying to explain you something tough, but somehow when we are explaining this equation, I feel like that I must tell you these things. Otherwise, you can ignore and questions will be simple. Don't worry about it. These type of questions. This type of question. Let's do it fast, okay? 32 question. This one. Melting of solid. Is it increase or decrease? Entropy is increasing or decreasing? Is increasing, plus sign. Sublimation. Sublimation means solid to gas straight away. Increasing, decreasing is increasing. Freezing. Freezing means liquid to solid. Decreasing. Very good. Who is this? Sammy. Very good. Mixing. Mixing two solutions. You know, in nature, everything is in the form of mixture. Why? Mixture means more randomness. So when you are mixing two things, randomness has increased. Okay, it increases. Remember this. Mixtures have more entropy than pure substances. Okay. Separation. Now tell me what is separation? It's decreasing. Yes. Boiling. Boiling is boiling means liquid to gas, increasing. Simple questions, right? But here they are talking about entropy of the system. This is entropy of the system. If I change this question to entropy of the surroundings, entropy of the surroundings, then this plus will become minus. This will be minus, right? Reverse sign. Very good, Sanvi. This is plus. This is minus. This is plus, and this is minus. So based on this, can you answer this question? Here they are talking about the delta S of the surroundings. Yes, yes, Atharva. Delta S surroundings is equal to minus delta S system. Okay. If entropy of the system is decreasing, it means entropy of the surrounding is increasing. Now this one, liquid to gas, this is system. Sammy is saying decreasing. Surrounding is decreasing because delta S system is positive. So delta S surroundings will be negative, right? Very good. What about B? Gas to solid. So first you decide delta S system and from there decide delta S surroundings. So gas to solid system is decreasing, surrounding is increasing. Very good. Perfect. Any doubt here, Yusuf? Is it clear? Okay, great. Now let's do this question. I gave you the equation of delta S surroundings. That will be given to you in the exam also. Is minus delta H system over temperature. So delta H of the system is given. This reaction is the system. Temperature is given. So you can plug in the values, and the value is minus 2221. Take care of the units, kilojoules over temperature. Temperature has to be in Kelvin, children, always in all calculation, remember? So it is 298 Kelvin. So what is the unit of entropy? Unit of entropy. Yes, units. Work out the units, Yusuf, from here. No, 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 Sanvi. Work out the unit from this equation. Yes, yes. In fact, delta H generally is given as kilojoules per mole. Right now it's not given, otherwise it's given like this. So unit will be joules per mole Kelvin. That's the unit of delta entropy. Remember this unit from this equation. But right now, this is given to me in kilojoules, so it is kilojoules per Kelvin. That's the unit. Jyoti, your answers are not coming. Jyoti, you are there? Okay, good. How many sig figs? Sig figs will be decided by these numbers. So how many sig fig? For the answer, 3. Very good, Sammy. Atharva, good. How to do this one? You see that in this process, your delta S surrounding is positive. You'll get a positive value. But in this process, which is endothermic, let's see delta S surroundings is minus delta S system, minus 112 kilojoules, this value, and put a minus divided by 298. This value is negative. So this delta S surroundings is negative. The above was positive, right? So we are good with these questions, simple questions. Let's see this question. Ethane thiol, which is also called as ethyl mercaptan. You need not to worry about the names. It's a thiol sulfur containing compound. You know, rotten eggs, they have a very different smell. That smell is due to sulfur, this SH. The boiling point is this. Heat of vaporization is this. What is the entropy of vaporization? Entropy of vaporization will be, yes, this is for the system, not for the surroundings. So you will take delta H of the system. Don't put minus now, okay? Of the system over temperature. This time I'm not placing minus, Yusuf, because I'm calculating entropy of vaporization of this substance, which is system. This substance, ethane thiol is the system. So we are talking about that. So don't put minus here. And what is delta H system? 27.5 kilojoules per mole. And what's the this temperature is the temperature at which boiling starts, means the boiling point, 35. So 35 plus 273. How much is this? This is in Kelvin. So answer will be kilojoules per mole Kelvin. That will be the answer. And the answer will have 3 significant figures, right? 0.5 divided by 308. So your answer will be 3. And your answer will be very small. That's why generally entropy, if you see, this answer will be in decimals. So entropy generally is measured as joules, not kilojoules. Because in kilojoules, the value will be very small. Yeah, so take it in. This is, you're giving me two significant figures, Sammy. So right now there is no need. Are they asking in joules? But otherwise we can do that. I can leave my answer here only. So give me three significant figures. Sammy, three sig fig. You are giving me two. Leading zeros are never counted. So I can leave my answer in kilojoules. That's not a problem. But generally it is given in. Sammy, when you give me the answer in three significant figures, that will be 0.0893 kilojoules per mole Kelvin. As I said, kilojoule is making this number very small. So if you convert this into joules, the answer will be 89.3. I'm getting this. Jyoti, is it okay? Jyoti, you're not answering. Sanvi, Jyoti, answer is correct. So I'm giving you now new equation that delta S naught of the system, not surroundings. I'm not talking about surroundings now, is delta H naught over the temperature. If you are talking about vaporization means boiling, then it will be delta H naught vaporization over the boiling point. If you talk about fusion means melting, then it will be delta H naught fusion over the boiling point, melting point, sorry, melting point. Fusion means melting. If it is sublimation, these are phase changes. The phases are changing, solid, liquid, gas. Then it will be delta H naught sublimation over sublimation point. Sublimation point. Is it okay? Can you do this question, children, now? 38. Enthalpy of vaporization is given. Entropy of vaporization is given. They are asking the boiling point. So I will use this equation, right? This one. Let's do it. So delta S vaporization is delta H vaporization over the boiling point. Vaporization means liquid to gas, right? Now plug in the values, but take care of the units. This unit is joules per Kelvin per mole, and this unit is kilojoules per mole. So you have to convert either this into joules or this into kilojoules. So what is the boiling point, children? Delta H of vaporization 58.51. I'm just converting that into joules per mole divided by 92.92 joules per Kelvin per mole. Mole and mole cancelled, joule and joule cancelled, and you'll get your answer in Kelvin. And you have to put your answer in four significant figures. Sanvi, are we good with this question? Mathematics I'm leaving. You can do it, I know. So that will tell you the boiling point of the mercury. You'll get the boiling point of mercury. You know mercury is the liquid. It's the only metal in the liquid form. Sanvi is giving me the boiling point. Sanvi. Atharva is giving me something else. Sanvi is giving something else. Anyone else confirming this answer? Yusuf, you're the mathematician of the class. Answer it. Jyoti, check the answer. Sanvi is correct. Yes. It is 629.68. So I can say 629.7. So Sanvi, your answer is 6.3. You are giving me answer in two significant figures. Answer should be in four sig fig. So those who are giving me in two significant figures, they all are wrong, right? Answer is in four significant figures. Moving on, children. So that's the concept of your entropy. These are simple questions. Let's do them very fast. Predict the sign of the entropy change during the reaction. Entropy of the system. They have not mentioned anything, so it means it is entropy of the system. Yes, children. Is it increasing or decreasing? You have to see the products minus reactants. This is for the reaction. So there is a gas on the reactant side, but on the product side, they all are solid. So entropy of the system is decreasing, negative. Check this one. N2H2 ammonia. These are very popular questions for AP exam. I hope first question is clear. You have to compare the state of the product and that of the reactant. Whatever side gas is there, that will have high entropy. Okay. Now look at the B part. In the B part, this is gas, this is gas, this is gas. So how should I compare? How many moles are here? How many moles? 4. How many here? 2. So is it increasing or decreasing, Atharva? No, I'm not getting. This is not a mixture. You're getting out a reaction. So they are just asking when this reaction is happening, the entropy is increasing or decreasing. The answer is it's decreasing, right? Ammonia is not a mixture. Ammonia is getting formed over there as pure substance. Okay, it's a chemical reaction. You're making ammonia. So here entropy is decreasing. Now let's see the C part. Yusuf, Jyoti, you are not answering questions. Compare the reactant, which is a solid, and the product, they are aqueous. So what is happening to entropy here? Increasing, right? Now compare this. Can you answer this? This is very simple. All of you can answer this. Yusuf, it is, in this case, this is solid. This is liquid. It's increasing. Come on. I'm talking about D part. Solid to liquid. Entropy is increasing or decreasing? Jyoti, Yusuf, Sanvi. So Jyoti did the error. Yusuf and no, Sanvi did the error and Yusuf and Jyoti. And you're not reading the question, both of you? It's increasing. Very good, Sammy. This is increasing. Now, please, this is very simple question. Learn it today only. You don't require to practice it again and again. It's a very simple question. Graphite and diamond. Do you remember the structure of graphite? It has ring kind of structure with delocalized electrons. Every carbon is bonded to 3 more carbons, and then there is a free electron on every carbon. That free electron is delocalized on the complete structure. That's why graphite is a good, yes, covalent network. But there is a delocalized system of the electrons. Electrons are moving, they are delocalized. Whereas in diamond, every carbon is bonded to four more carbons. There is no free electrons, very hard structure, very compact tetrahedral units like this, like this. This is compact, very hard, nothing is moving. So, which one has more entropy, the diamond or the graphite? Graphite has more entropy. Remember this. This we have done in covalent network solid when we were discussing about the network of the graphite and diamond. Graphite is soft, slippery to touch, and graphite is good conductor of electricity. Watch the video and try to go through this structure again. So graphite has more entropy. You know, children, they say that all the diamond of the world is slowly, very slowly is getting converted into graphite. Why? Because graphite has more entropy. So diamond has less entropy. Diamond is hard, less freedom. So very slowly the diamond is getting converted into graphite. Okay, answer this B part. Which one has more entropy? Hmm. Very simple question. Check their states. Yes, very good. Answer C part. Which one has more entropy? Yes, very good. Okay, so that's about the entropy, introduction of the entropy, meaning of the entropy, and how you can compare the entropy of the products and reactants. And nature wants high entropy. Nature is in the favor of more entropy. Now let's see the third law of thermodynamics. They say when you have a perfect crystal at 0 Kelvin, you already know this temperature, 0 Kelvin, which is also called as absolute zero. This is the lowest possible temperature. At that time, if the it is a perfect means pure, 100% pure. If some compound is in perfect crystalline form at this temperature, then we assume that the kinetic energy is nearly zero because kinetic energy is proportional to temperature. If this temperature is zero, kinetic energy is zero, right? No kinetic energy means no randomness. So for a perfect crystalline form at 0 Kelvin, we assume that entropy is zero. Only at that temperature. Otherwise, no. So what does it mean? It means that under normal condition, none of the compound will have zero entropy. All the compounds will have a positive entropy, a positive value. You check the table of entropy table where they have given the values for entropy of different substances. They all have positive value. None of them have negative value because the lowest possible value of the entropy is zero. And there is no value below zero, right? And this value is zero only at 0 Kelvin. But most of the time, things are above 0 Kelvin. So it means none of the compound will have zero entropy. To get zero entropy, it has to be a perfect crystalline form, right? We are good with this? So entropy depends on temperature that you already know. High temperature means high entropy. Let's try to do this question. Which one has more entropy? This one or this one? Yes, because this one is assumed to be zero, right? This is zero entropy, but this is higher than zero. Okay, check B part. This one or this one? Now, this is a different question, children. You cannot answer this. So I have to explain you few more things, then you can answer this question. Right now, if you see, temperature is same, pressure is same, everything is same. It's a gas, it's a gas. How to compare their entropies? The bonds. In N2O, there is a bond between nitrogen and oxygen. These bonds, they can vibrate. Chemical bonds, they vibrate. Whereas in helium, is there any chemical bond? No. So the molecules with more bonds have more entropy. This is an atom. There is no chemical bond. Say though there is no vibrational, rotational motions. If you remember electromagnetic spectrum, unit 3, there we discussed that how these vibrational motions are measured with the help of IR. So bonds can vibrate like a spring. You can stretch them, you can compress them. Stretching, compressing, all these are randomness. So, what's the answer, children? If you are listening very carefully, then answer this question. Which one has more entropy? Which one has more entropy? I hope you are listening. Mhm. So, Sanvi, you were not listening. Yes, Jyoti, why? Now, Atharva, Jyoti, can you answer why? Sammy, Yusuf, Atharva, Jyoti are saying N2O and but why there is more randomness, Jyoti? No, gas. This is also gas. I explained you in detail. In N2O, there is a chemical bond with oxygen here, with nitrogen here, right? These bonds can undergo stretching, compressing, vibrational motion. And you can say this also, what Atharva is saying, more protons, more electrons, more randomness, more atoms. Yes, Sammy, you're getting it now? This molecule has more randomness because it has more electrons, more bonds, more atoms, more protons, more neutrons, crowded. Whereas helium has no chemical bonds, right? So please retain it. Sanvi, are you clear about it? Sanvi? Okay, good. This is a very unique question. They may not ask this question in AP, but I place it because it's a good question. Now let's see the C part. This is easy. Can you answer? Very easy. Which one has greater entropy? This one or this one? Temperature is same, you can see. So which one has greater entropy? Answer it fast, children. Yeah, liquid. Liquid, yes. Okay, now we are done with the entropy concept. Now we are going to discuss about Gibbs free energy. Remember I was telling you the second law of thermodynamics, that delta S of the universe should always be greater than 0. If it is greater than 0, then that process is spontaneous and will take place without any efforts. But if that delta S universe is less than 0, process is non-spontaneous. So what they have done, they have made another thermodynamic function, Gibbs free energy, which is represented as delta G. G means gives free energy in the universe, free energy which is helping in changing the seasons, formation of days. Everything needs energy. Formation of days and night is due to the motion of the earth, right? Earth motion is taking energy. It's not happening without energy. But are you giving that energy? No. So that's why we call it as free energy, right? So Gibbs free energy will make the process spontaneous or non-spontaneous. So let's see how. So we're going to define this Gibbs free energy in terms of system and surroundings. So let's talk about an equilibrium process. A is in equilibrium with B. What does it mean? It means reaction is spontaneous, is going from A to B and is also going from B to A. In this process, delta S universe becomes zero because reaction is going equally in both the directions. So for the equilibrium process, universe entropy is zero. Is it okay? Okay. So let's take this equation. Delta S universe is delta S system plus, remember delta S surroundings? We defined it as minus delta H system over temperature. You remember that? Let's plug in here. Minus delta H system over temperature. Can I write it like this, children? Okay. Now, just get rid of this minus. Put minus here. When I put minus here, this becomes minus and this minus minus will become, this will become plus, right? Is it okay? What I did, I multiply the whole equation by minus. In fact, what I'm going to do, I multiply the whole equation by minus t. Now let's see. Minus t delta S universe is now this t minus t delta S system plus delta S system. Can you see this equation? This quantity is defined as delta G. This is delta G, children. And that delta G is delta H system minus T delta S system. Is it okay? You're getting it, children? So this derivation of the equation, don't worry. You need not to memorize it and you need not to practice it. But you have, now I derived the equation just to show you that how it is formed. Now, can you decide the sign of this delta G? Let's decide the sign of delta S. What do you want delta S universe, positive or negative for a spontaneous process? What sign do you want for the universe? Positive. Increase in entropy. Remember, second law of thermodynamics, entropy of the universe is increasing. You want positive, right? You want this to be positive. This can be, if this is positive, but this complete symbol is negative, right? So what should be the sign of delta G? Delta G must be negative. Yes, Sanvi. Because T delta S universe should remain negative. Delta G is negative for a spontaneous process. Now check. If delta S universe is negative, if this is negative, now Sammy, what will happen? This is negative, this is negative, negative, negative will become positive. In that case, your delta G value will be positive. But negative, universe doesn't want. So what does it mean, Yusuf? It's a non-spontaneous process. Non-spontaneous. A rocket is going up. A rocket is going up. What is the sign of delta G for this process? What is the sign of delta G for the process? Rocket going up. Positive. Delta G, which you can calculate by using this equation, that delta G is equal to delta H minus T delta S. If I put not here, delta G naught, delta H naught, delta S naught, means not means standard conditions. Standard conditions. Children, you are getting it? The meaning of spontaneous and non-spontaneous, the sign of delta G. Memorize it right away. So the processes which can take place on their own, they are spontaneous processes. If for that, delta G has to be less than 0, means negative. If delta G is not less than 0, if it is greater than 0, if it is positive, then the process is non-spontaneous. Is it okay? And delta G is equal to 0. It is equal to 0. See, 0 here. So when delta G is 0, it means reaction is in equilibrium. But this is delta G. This is not delta G naught. Right now we are working with delta G. Please understand there is a difference in delta G and delta G naught. What's the difference? This is standard conditions and this is non-standard conditions, right? So what is the sign of delta G for a spontaneous process? I'm just checking, do I have questions here? Okay, there are questions, yeah. What is the sign of delta G for a spontaneous process? Sanvi? Spontaneous process. I think I asked spontaneous, right? Sign of delta G for a spontaneous process, children? Yeah, please all of you type it. Delta G is negative for a spontaneous process. Jyoti, Sanvi, you're getting it? It's written here also. If the rocket is going up, is it a spontaneous or non-spontaneous? It's a non-spontaneous. What is the sign of delta G for this? Positive. Rocket is falling down. Rocket is falling down. Spontaneous. What is the sign of delta G for this? Negative. So understand this. Okay, now I'm taking you. Another important concept, that delta G depends on delta H minus T delta S. You already know the meaning of delta H. Enthalpy change. You know delta S, entropy change. T is the temperature in Kelvin. Let's try to understand the meaning of this table. If your process is endothermic, so I'm going to hide the table. I want you to work with me. So start answering. If delta H is positive and delta S is negative, what will be the sign of delta G? This is positive and this is negative. What will be the sign of delta G? See, I've given you some positive value of this, some negative value of this. This negative and this negative will make the answer positive. So delta G will be positive. Is there any way that you can make this delta G negative by changing the temperature? Temperature is the only variable. Just think about delta G is the driver of a reaction. It's the driver, right? But this driver has only temperature as the variable. So during the reaction, when the reaction is driven, then temperature we can increase or decrease the temperature. We cannot do anything else. So my question is when delta H is positive, delta S is negative, delta G is positive. Is it at all temperature? Is this condition at all temperature? The answer is yes, all temperature. Can you make out this? Whatever is the temperature, because this value is positive and this value is negative. And due to this, this complete factor is positive. Positive, positive will make your delta G positive. It doesn't matter what's the temperature. High temperature, low temperature, whatever is the temperature, delta G will be positive. If it is positive at all temperature, is it a spontaneous process or non-spontaneous process? This one. Spontaneous or non-spontaneous? I hope you are understanding. Delta G is positive. Is this process spontaneous or non-spontaneous? Atharva, Sammy, I'm audible, right? Yeah, it is non-spontaneous. Why you're not answering? Delta G positive, non-spontaneous. Atharva, Sanvi? Okay, now answer my next question. Delta H is positive. Delta S is positive. Means, now check. Delta H is positive. Delta S is positive. So this complete number will become negative, right? So is this process spontaneous at all temperature? Now you have to understand this is negative, right? So it means if this T delta S, which is negative, if it is greater than delta H, only then delta G is negative. Only then delta G is negative. Are you getting this? Sammy, you're understanding? See, this value is negative, this one. If this complete value is greater than delta H, which is positive, only then my delta G will be negative, right? But how can I ensure that this T delta S should be greater than delta H? How can we ensure that? You have only one variable in hand, and that is temperature. So this process is spontaneous, will give you a negative delta G at high temperature. When this temperature is high, if I'm confusing you children, please, you can stop me. If this temperature is high, only then this T delta S value, which is negative, will become greater than delta H value, which is positive. This will ensure that your delta G is negative. Is it okay? You're getting it? So this process is spontaneous at high temperature, spontaneous. The above one is non-spontaneous. Non-spontaneous at all temperature, the first condition. But the second condition is spontaneous, right? Now please work with me. Sammy, you're there? Yusuf, Sammy, I'm giving you next example. Delta H is negative. Delta S is negative. Now tell me at what temperature the process is spontaneous, low or high? Check. This is negative, this value. This is also negative. So what happens to this value? Becomes positive. What do you want? Which one should be greater? T delta S here is positive and delta H here is negative. What do you want greater? Negative value or positive? You want negative value to be greater. How can we have this negative value greater? At low temperature. I think Atharva is answering correctly. Low temperature. Then this delta G will be negative. You're getting it, Sammy? Why we want delta G to be negative? Because only then it will be spontaneous. Otherwise, process will not happen. So we are looking at the temperature. Oh, what temperature can make my process spontaneous? But for that, if delta H is endothermic, which nature doesn't want, nature is in favor of low energy, not of high. Endo means high energy. If delta H is positive, entropy is decreasing, both of them are working against nature. In that case, delta G is always positive, irrespective of temperature. Low, high, it will be non-spontaneous. But if one of them is favoring, like here, delta H is favoring, second condition, delta H is favoring, then you can manipulate temperature to make it negative. Here, delta H is favoring, so you can again manipulate. Fourth and the last condition, this is negative, this is positive. Nature wants low energy, negative energy. Nature wants high entropy. Don't you think both the factors are in favor? So, at all temperature, your delta G will be negative. You can check it. Check here, children. Last condition, fourth condition. So I'm writing the fourth condition here. This is negative and this is positive. So this complete value will remain negative. Negative, negative, delta G definitely negative. It doesn't matter what's the temperature, low, high, it's going to be negative. So at all temperature is going to be spontaneous. Check. This is what we were discussing. Here entropy is in favor. This is not in favor. So you keep temperature high so that this number becomes greater. In this case, none of them is favoring. So at all temperature, the reaction is non-spontaneous. In this case, this is favoring. Keep temperature low. And this is also favoring. Sorry. In this case, both of them are favoring. Sorry. So at all temperature, spontaneous. But in this case, this is favoring. This one is not. So keep the temperature low. Children, you are getting it? It's a very important table. And if a reaction has A is in equilibrium with B, delta G for this reaction, delta G naught for this reaction is minus 130 kilojoules per mole, not minus plus. So what does it mean? That the process is non-spontaneous. But the process is non-spontaneous for this direction. The same process is spontaneous in the reverse direction. If I write down this reaction in the reverse manner, delta G naught will be minus 130 kilojoules per mole. So a process which is non-spontaneous in one direction will become spontaneous in other direction, in the reverse direction. So this question can be there. This is delta G naught for a substance, for a reaction, like this is the reaction. Delta G naught for this reaction will be summation of the delta G naught formation of the products. What are the products? C and D. See, delta G naught formation and multiply by their coefficients. The value will be given to you in the form of table. Minus summation of delta G naught formation of the reactant. So we'll use this equation. This equation you are already aware, and you are aware that delta G naught formation will be 0 for pure elements. Like for delta H naught formation for pure elements was 0. This we did in unit 6. So exactly in the same way, delta G naught formation is 0. So we'll work more with questions to understand this equation. Ready for the question, children? Now your turn. There are plenty of questions. Move fast, okay? Equation is delta G is equal to delta H minus T delta S. Equation will be given to you in the exam. We are doing A part. They are saying the values of delta H, delta S, temperature given. So they are saying which process will be spontaneous. Means you just plug in the values and check the sign of delta G. If delta G is negative, spontaneous. If it is positive, non-spontaneous, right? Let's plug in the values. So it is 25 kilojoules, this one, 25. Temperature, 300. Delta S plus 5. But this one is joules and this is kilojoules. So you divide this by 1000, right? Check the answer. 25 minus 1.5. Is the answer negative or positive? This one. I'm doing here. You can do mathematics. Yusuf, do this mathematics. Is the answer negative or positive? Please take care. Joules has to be converted in kilojoules because this is in kilojoules. Any one of you doing it? Atharva? No one is doing? I just plug in the value of delta H, this one, T, this one, delta S, this one, but I divide it by 1000. And then I multiply it and I'm getting this. And I'm just asking a very simple question from you people, that is this answer positive or negative? Positive. So this process is spontaneous or non-spontaneous? Can I make this process spontaneous, children? How can I make this process spontaneous? Yes, increasing the temperature. Very good, Atharva. You were listening very carefully. You increase this temperature, make it more higher so that this value becomes greater than 25. Then answer will be negative. Let's see the B part. You're doing the B part, children. Delta H is 25. Delta S is 100 and temperature is 300. So 300 times 100, this is in joules. Divide by 1000. Is this answer negative or positive? This answer. I'm getting 25 minus 30. So this answer is, yeah, Jyoti, answer is, Jyoti, Yusuf, answer is negative. So this process is spontaneous. B process is spontaneous. Let's check the C process. C, delta H is minus 10. Minus, I'm using this equation every time. What is the temperature? 298. What is delta S? 5.0. But this is again in joules. Divide by 1000. And I'm sure this answer is definitely negative, right? Because this is minus, this is minus. So answer is negative without solving. So C is also spontaneous. Now I want you to check D, all of you. Equation is delta G is delta H minus T delta S. Take care of the units. This is joules. And tell me, delta G is negative or positive? Yusuf, D part. D for delta. You're doing it, Yusuf? You're saying it's negative, right? Yusuf is saying D is negative. Is he right? Okay. So Yusuf is right or wrong, children? Waiting for the answer. He's right. Okay, great. Great, Yusuf. Very good. Okay, now let's do the question 36. So these questions are very simple. If you know the concept, you have to just check the sign of delta G. Check this 36. At what temperature will the process spontaneous? That's the question. So you know that delta G is equal to delta H minus T delta S, right? That you know. To know this question, you want your delta G to be negative. So they're asking at what temperature. So what I'm going to do, I'll put this delta H minus T delta S equal to 0. Let's assume the process is in equilibrium. Equilibrium means, what is the meaning of equilibrium? That delta G is 0. That's the meaning of equilibrium, right? Okay. Now, can you tell me how to calculate temperature? Don't you think that temperature is delta H over delta S? Let's calculate temperature in every case. A part. Delta H is minus 18 kilojoules. Delta S is minus 60 joules. So I have to convert that into kilojoules. So it will become minus 0.060 kilojoules. This minus and minus cancel. What's the answer, children? Mhm. Temperature will be positive only. It will never be negative. Kelvin temperature is always positive. What's the answer? Okay, 300 K. 300 K. You're going to plug in only the positive values because temperature has to be always positive. But the question is 300 K is the minimum needed temperature. Do you want temperature higher than 300 K or lower than 300 K? That's the question. 300 K is equilibrium. Equilibrium means reaction is equally going in both direction. But you want the process to spontaneous to go more in the forward direction. So do you want high temperature higher than 300 or lesser than 300? That's the question. Check. Delta H minus T delta S. Delta H is negative. Delta S is also negative. This negative and negative will make this factor positive. Positive will make delta G positive, right? So what do you want? This positive to be greater or lesser? Do you want this plus T delta S greater than or less than delta H, which is negative? You want it less, right? So temperature has to be lesser than or equal to 300 K. Are you getting this answer, children? Sammy, where are you? Sammy, are you have understood this? Why I'm writing this temperature less than or equal to 300 K? So if the temperature is 300 or less than 300, the delta G will be negative. Otherwise, delta G will be positive. The way I answered this question, you are going to answer B part. B. So what is T? Same equation. 18 divided by 0.060. You are again going to get 300 K. Again 300. But this time, now let's go back to the equation. I'm using a different color for the B part. What's the sign of delta H? Positive. It's not going to favor negative delta G. What's the sign of delta S? Positive. So this complete number is negative, right? Minus T delta S. This will remain negative, this one. So you want this minus T delta S to be greater than delta H, right? Because delta H is positive. You want your answer to be negative. So what do you want? Low temperature, high temperature? Children, I'm speaking a lot, so I'm just thinking that whether you are understanding or not. Sammy has answered. Very good. So for the second, T should be greater than or equal to 300 K. Yes. You're understanding this, children? This is what on the table I was explaining when you were very quiet, not asking any question. Now, here, this is a question which can help you in understanding that what process needs high temperature, what process needs low temperature. The aim is to make delta G negative. Ready for the next C part? Yusuf, you will try. So, delta H minus T delta S is delta G, which you can put it equal to 0. From here, rearrange the equation, get temperature as delta H over delta S. Plug in the values. Don't take this negative because temperature will never be negative. And I think I'm again getting 300 K. Am I right? Again 300 K. Now, what do you want? You want the process to be spontaneous. So, do you think the process will be spontaneous for the endothermic? And this is negative. So, what's the sign of delta H? Positive. What's the sign of this complete factor? Positive. So, what will be delta G? Positive. At all temperature. Yes, Sammy, good. So, delta G is positive at all temperature. This process, this one, C, is non-spontaneous. Non-spontaneous. At all temperature. Right? We are good? Now, check for the D part. Temperature here again 300 K. Same values. But now you have to see, do you want temperature higher or lesser? to make your delta G negative. What's the sign of delta H? Negative. What's the sign of delta S? Positive. So this complete factor is also negative. Negative and negative will make your delta G negative. So D is a process which is spontaneous at all temperatures. Sanvi, are you understanding this? I hope you are understanding, all of you. So this is spontaneous at all temperature. It's going to be spontaneous at all temperature. Is it okay, children? Can I test you for the table now? I'm testing you for the table. The question 36 is based on that table which we were making earlier. So all of you ready? Try to answer, okay? Delta H, delta S, T, delta G. Aim is to make delta G negative. If delta H is positive, delta S is negative, at what temperature delta G will be negative? Or will it be negative or not negative? Just tell me about it. You have to think in terms of delta G is equal to delta H minus T delta S. Yes, Jyoti, can you answer this question? At what temperature can I make delta G negative? Can I make it or I cannot make it? Aim is to make delta G negative. Mhm. Yusuf? Atharva is saying low temperature. Is it right, children? Atharva, did you try this? Delta H is positive, right? Delta S is negative. So this negative and negative will make this factor, complete factor, positive. Do you think under any condition you can make delta G negative? Yes, Jyoti, you're right. So can I say that at all temperature, delta G will be positive? Atharva, you're understanding? Sanvi? At all temperature, because remember this, endothermic, give me one second. Endothermic and decrease in entropy. These processes, they make delta G positive. And here, both of them are, this is endothermic, this is decrease in entropy, right? So at all temperature, delta G will be positive. Okay, Atharva? Giving you second condition. Those who are not answering, Yusuf, try to answer. Delta H is positive. Delta S is also positive. It means delta S is favoring delta G, negative. Do you want high temperature, low temperature? Sorry. Do you want high temperature, low temperature? Use the equation again. Waiting for the answer, children. This is positive. This is also positive, so this number is negative. You want your delta G to be negative. So, do you want high temperature, low temperature? Mm-hmm. Very good, Jyoti. High temperature. Sanvi, if anything not clear because you're not answering, so if you're confused, please start asking questions. Next condition. This is minus, and this is also minus, right? Minus, minus. So delta G is delta H minus T delta S. This is minus, and this is also minus, so this complete number is plus. What do you want? You want minus to be greater. I think Jyoti has understood this. That's why she is answering very fast. Atharva, so this is low temperature. Semi, because if you keep this temperature low, this positive value will become, this is mathematics. Aim is to make this delta G negative. So if I keep temperature low, then this complete positive value will be lesser than delta H. So at low temperature, this process is spontaneous. Try to answer the last one, children. Delta H is negative, delta S is positive. What do you think? This is negative, this is positive. So this complete expression will be negative. So this is at all temperature. Yes, yes, yes. Sanvi, you are there? Are you understanding this, dear? Because you are not answering. Which last? This one? What is the aim? Can you tell me what is the aim? The aim is to get delta G negative. Okay, negative means spontaneous. Very good, Sanvi. And the equation is this. This is the equation. And in the last example, reaction is exothermic. So this delta H is negative. So that's going to favor my delta G. I want delta G negative. Delta H is negative. Entropy is positive. This one. So this complete number will remain negative. Both of them are negative. So whatever is the temperature, high, low, it doesn't matter. The answer will be negative. You take low temperature, still you will get negative answer. You take high temperature, still the answer will be negative. So at all temperature, delta G will be negative. Okay, great. Yusuf, you also didn't answer anything. Yusuf, you have understood this? Okay, moving on, children. Values are not given. So how to do this type of question? Values will be given to you. Okay, right now values are not given, but in the exam, values will be given to you. So how to do? So I will use this equation that delta G naught is equal to delta G naught formation of the products. Summation. Summation means these two products minus summation of delta G naught formation of the reactant. Values will be given to you. Now you have to just plug in 12 CO2. So 12 times delta G naught of the CO2 plus 6 times delta G naught of the H2O, this H2O. And it should be liquid. In the table, gas will also be written. It's a thermochemical equation, liquid, solid, gas. You have to take care of that. So this is your react products, this one, products minus summation of reactants, right? This reactants, this one. 2 times delta G naught formation of C6H6 plus 15 times delta G naught formation of O2. This is reactant. Take care of these coefficients. This one. They should be the part of your calculation because in the table the values will be given for 1 mole. Like delta G naught formation of CO2 is this much value per mole. But here right now, how many moles are there? 12. So you have to multiply it by 12. So these questions are very simple. You can see that here the values are plugged in. What's the sign of this delta G after calculation? What's the sign of delta G? Please answer fast. Can you see this delta G value? It's negative. So the reaction is spontaneous or non-spontaneous? Answer this. It is spontaneous reaction. Very good. So these type of questions, simple mathematics. Okay. Now Gibbs free energy and chemical equilibrium. We have understood the meaning of Gibbs free energy. Delta G, spontaneous, non-spontaneous. Now let's try to understand chemical equilibrium and delta G. So I'm going to ask some question what we have done earlier about the equilibrium constant. Let's say there is a reaction. A is in equilibrium with B. K value is 1.0 times 10 raised to power minus 6. Is this K value greater than 1 or less than 1? Yusuf, this K value is greater than 1 or less than 1? Look at the value. Yes, all of you, please answer. It is K is less than 1. You remember what's the K expression? Equilibrium constant expression? It is the, yeah, any one of you? K, equilibrium constant. We have done K, Q, KSP, dissociation constant, Ka, Kb. Remember? So what's the K expression? Concentration of B over concentration of A. Agreed? If K is less than 1, then what does it mean? What is more? B is more or A is more? It means the concentration of B is less than concentration of A. So what does it mean? The reaction is spontaneous or non-spontaneous? Because product is less, reactant is more. Yes. So if K is less than 1, delta G will be positive. Very important relationship. If K is less than 1, it means reaction is non-spontaneous because you are not getting much product. Very good, Sanvi. So mathematically, we can relate them. Now let's say this reaction. C is in equilibrium with D. K value is 1.0 times 10 raised to power 6. This K is greater than 1. K expression is concentration of the product divided by concentration of the reactant. Now this K is greater than 1 means the product concentration is more than the reactant concentration, right? Now this reaction is spontaneous or non-spontaneous? This one. K is greater than 1. You have more products than reactants. So this one is spontaneous. If it is spontaneous, why it is spontaneous? Because products are more. If it is spontaneous, then delta G is negative. Sammy, you're understanding this? Okay, good. So it means this equilibrium constant K is related to Gibbs free energy. How? Mathematically, delta G is delta G naught minus RT ln Q. Remember Q, the QSP, QA, Q is the reaction quotient. It's the condition when the system is struggling to come into equilibrium. Q has the same expression as K. But Q is the condition when the system is fighting to become equilibrium. So when Q is equal to K, then system is in equilibrium. We have done a lot of question on Q also. So when Q is equal to K, system is in equilibrium. And when the system is in equilibrium, delta G is equal to 0. This delta G, 0. Remember in the first slide I was showing you, Gibbs free energy for an equilibrium is 0. Reaction is equally spontaneous in both directions, is 0. So 0 equal to delta G naught minus RT ln K. So rearrange. Delta G naught is RT ln K. That's the relation I'm talking about. Now let's talk about this K. If this K is greater than 1, then ln K is a positive answer. Positive. And this complete, I did some error. This is plus, sorry. And there is a minus here. Children, do correction. This is plus. And there is a minus. So if this K is greater than 1, then ln K is a positive answer. If ln K is positive, then delta G naught is negative in this equation. And if this K is less than 1, ln K will be a negative answer. And in that case, delta G naught will be positive. So many questions are there on this concept. I hope you're understanding this. If K is greater than 1, it means reaction is favored for products, means products are more. If products are more, delta G has to be negative. Only then products are formed. K greater than 1, ln K value will be positive. When you're going to plug in here, your answer will remain negative. Delta G negative. K less than 1, products are less, reactants are more, ln K is negative, delta G is positive. So that's the relation between delta G naught and K, equilibrium constant. That's the equation I was talking about. Earlier I did error. In place of plus, I took minus. No, it is plus. So this is the equation. Is it okay? This is the table. Ready for answering my question, children? Ready? If K is greater than 1, here, condition 1, this one, ln K will be positive or negative? If this K is greater than 1, ln K is very good, Atharva. If ln k is positive, delta G naught is in this equation negative. The reaction is spontaneous, right? Very good. If k equals to 1, this k is 1. What is the value of ln 1? 0. Ln k is 0. Delta G naught will be 0. So in that case, reaction is equally spontaneous in both directions. Delta G naught, that's why it is 0, right? Products and reactants are equal in amount. If k is less than 1, this condition, Jyoti, Sanvi, try to answer. K is less than 1. Ln k will be minus. Delta G naught will be plus. And the reaction will be non-spontaneous. Very good. Now the questions will be very simple like this. Look at this question. We have time, right? Yes, 10 minutes are there. So we can do few questions on this concept. Okay. So before you start this question, let me give you a review. If there is a reaction, A is in equilibrium with B, B is in equilibrium with C. If I ask you to add these two reactions, the overall reaction is A is in equilibrium with C. If I say write down K expression for this one, K1 is concentration of B over A, K2 is concentration of C over B, right? What is K3? K3 is concentration of C over A. So when you add two reactions, the new equilibrium constant is the product of the equilibrium constant of the reactions which you have added. I added 1 and 2. Look at this K1 and K2. When you multiply these two, what happens? Just multiply them. You can see that B and B cancelled and you are left with C over B. So K3 is K1 times K2. This equation we have done earlier in unit 7. And we did plenty of questions also based on it. And I'm going to use this concept again here. Check. This is the overall reaction. How can I get this reaction from this data? So what do you need to do to get this reaction? You need to reverse this equation and divide by 2, H2O. Reverse this, H2O, giving you H2 and half O2. But what happens to K? Because you reverse the equation, when I reverse the equation, K becomes 1 over K. And I divide it by half. So this K is now, the new K dash is 1 over root K. A to B is K. So B to A will be 1 over K. If I divide the whole equation by this half, then it means K raised to power 1 by 2 means square root. So please review this from unit 7. So that value is now 1 over 1.8 times 10 raised to power 37 square root. This new K. And what should I do with this equation? I'll take it as such. I need H2O2. I'm taking it as such. So H2 plus O2 giving you H2O2. So this K will be unchanged, right? Now you add them. H2 cancelled. And this half O2 cancelled and you are left with only half O2 here. So the net equation is H2O plus half O2 giving you H2O2. That's the equation. What's the K value for this equation? The product of these two values. So 1 over square root of 1.8 times 10 raised to the power 37 times 2.3 times 10 raised to the power 6. Is it okay, children? So that's the K value, new K value. So this you have to review from unit 7. You can go and check this concept over there and you can watch the video, you can check my notes and do the quiz. What is this answer? Can you work out the answer, children? What's the answer? Any one of you doing it? I'm getting 1.7. Sorry, I think I pressed a wrong button. Anyone else doing? Because I'm not getting this, Atharva. You know, it has to be square root. This has to be in parentheses. You did that? Did you place it in parentheses? Are we getting something 1.7 times 10 raised to minus 3? Can you check, Jyoti? Sami, Yusuf? Yusuf? No, 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 yes. Answer the question. I know that you are tired. I'm also tired, Yusuf. It's late night here. So help me. Now I'm getting the same answer as Atharva is getting, 5.42. Yes, Atharva, you were right. Oh, okay, okay. Yeah, yeah. Good. Perfect. So my answer earlier was wrong. Fine. Let's remove it. Is this value of k greater than 1 or less than? Oh, here is the answer. Minus 13. No units. K has no units. Is this value greater than 1 or less than 1? Less than 1. So what are you expecting delta G? Negative or positive? Positive. But they're asking you to calculate it. So delta G naught is minus RT ln K. R is 8.314. Temperature is 600 K given in the question. 600 ln, and you plug in this value. 5.4 times 10 raised to minus 13, and your answer will be in joules because this value is in joules. Joules per mole per Kelvin. This answer will be in joules. You can convert that into kilojoules, means divide the whole answer by 1000 and you should get this answer. Is it okay? And this answer is positive. You check. This is positive answer. So delta G naught answer will be here positive, because this complete ln of this value will be a negative answer, because this k is less than 1. So ln k will be negative. Negative and negative will make it positive. So delta G naught is positive 140 kilojoules per mole. Right? Okay, children. So we'll continue from here in the next class. Few more questions and then we'll be on the next topic, electrochemistry, unit 9 again. Okay. So tomorrow I'll see you at the same time. Bye bye. Have a nice day.